LLMs have shown remarkable capabilities in generating code. This allows users to get ideas off the ground faster by building UI prototypes and testing them on users. This process is called exploratory programming, and it's crucial for experimental projects where real design testing is more productive than upfront specifications. However, there is a gap in going from an abstract idea to a working solution. Converting an initial idea into a feasible design requires a detailed consideration of multiple aspects, such as the target user of the application, the approach, and the user experience. We present DynEx, an LLM approach that accelerates exploratory programming by combining design exploration with implementation. DynEx takes in an application idea as an input and outputs a functional UI. First, it guides users through a structured design exploration. Next, it iteratively implements the prototype using LLM code synthesis. We walk through DynEx with an example to create an app to learn Chinese. The user first traverses through a design matrix. The matrix helps the user explore the person, approach, and interaction, which is the core UI paradigm such as a table, card swipe, newsfeed, or chatbot layout. We brainstorm ideas for each dimension and select visual learner, space repetition, and quiz flashcard. Each dimension is explored on 2 levels of specificity, the first level being the idea, where DynEx helps brainstorm ideas, which is what we just did, and the second level being the grounding, which solidifies foundational details and specifies how each idea should be developed. The user grounds each idea in the matrix. After the design matrix is traversed, the user begins implementation in code. The system first identifies the project requirements, creates a spec, and then generates synthetic placeholder data if needed. In this case, it generates Chinese phrases and words to use in the prototype. Once the initial setup is complete, the system creates the prototype with modular stepwise implementation. We do this through step-by-step implementation and self-invoking multimodal LLMs. The system breaks down the implementation plan into steps and generates code for each step. The user can update or remove the step at any point. They can also debug the code at each step. This provides a simplified form of version control. And by self-invoking multimodal LLMs, our generated code can call LLMs to generate dynamic data and create images. We can then create applications that are not supported by static data, such as book recommendation apps, movie recommendation apps, and note sense-making apps. Here, we generate the code for step 1 to create the HTML structure. Then we generate the code for step 2 to implement the flashcards section, and then step 3 to implement the quiz section with spaced repetition, step 4 to implement the progress bar section, and then step 5, calling GPT to generate images. With this, our prototype for learning Chinese with images and spaced repetition is complete. The user can revisit the design matrix, tweak parameters, and also explore more variations. Here are some examples of other prototypes created using DynEx. To evaluate DynEx, we conducted a user study that focuses on the following research questions. Participants were asked to name a problem and explore concepts and solutions that would help solve their problem. We compared DynEx to Claude Artifact, an industry-standard tool, as the baseline. Claude Artifact is a chatbot where every prompt elicits a UI and code. Users can prompt the chat to brainstorm or add more features. We found that DynEx was significantly better at enabling users to explore more solutions, further develop their ideas, and create more feature-rich and complex prototypes. P6 wanted to create a friend event sharing and planning app, a Partiful but better. DynEx helped him explore a calendar-like interface, and he was really happy, stating that DynEx suggested many features to answer the foundational set of questions, such as how to match people with friends, how to visualize the friend sharing component, and how to join a friend's experience, bridging together non-obvious UI elements. P8 wanted to create an app to aggregate concert tickets based on value and settled on a table UI with DynEx. He stated that it was intuitive and feature-rich. He could sort by columns and sort by genre value for money. He liked the conciseness of the information presented in the table compared to Claude's standard newsfeed UI that had too much information, resulting in cognitive overload. He felt that DynEx better solved his problem. Overall, DynEx allowed users to have a more successful exploratory programming experience, bridging the gap between design and engineering to help individuals bring their ideas to life.